how many ways are there to mess up a Rubik's Cube? So obviously there's this way, that's like, it almost doesn't count. This is the solved state, but you can also do this, and this, and this. So that's 4 already. So that's 4 different ways that you can have a Rubik's Cube. But there are probably more. Actually, there are more, and we can calculate it. That's what we're going to be doing today. The first thing to realize about permuting this Rubik's Cube is that you're not really moving the tiles around. You're moving the cubies. So that's what these smaller cubes are called. And the second thing to realize is that there are 3 types of cubies that don't really mix. So there are edge cubies. Those are the ones that straddle 2 faces. Corner cubies are the ones that are on the corner of 3 faces. And then there are center cubies, the ones that have only a single face. And when I say these don't mix, I mean that the edge cubies will never occupy the same spots as the corner cubies. They're kind of in their own separate worlds. So that makes things a lot easier figuring out the number of permutations, because we just have to figure out the number of permutations of the corner cubies, multiply that by the number of permutations of the edge cubies, and then multiply that by the number of permutations of the center cubies. So, let's get started. For the corner cubies, there are 8 of them. There are 4 on the top and 4 on the bottom. So, that means that there are 8 factorial ways of arranging them. Let's start writing this down. Corner. So I said that there are 8 factorial ways of arranging the corner cubies. But that's not all, because within each spot that a corner cubie can take up, there are 3 orientations, because you can imagine flipping it and then flipping it again would take you back to the start. So there are only 3 possible ways each one can be oriented. Since there are 8 of them, that means that there are 3 to the 8 orientation states. But it's not quite that simple, because whenever you're rotating a Rubik's Cube, there are certain states that you can get to through legal moves, and certain states that you can't. So it turns out you can't orient an individual corner cube. You have to orient them 2 at a time. Ultimately, that means that 7 of the corners we can orient freely, but the 8th one is determined by the orientation of the others. So that means we really only have 3 to the 7 orientation states. So let's move on. The edge cubies. So how many edge cubies are there? Well, there are 12. There are 4 on the top face, 4 on the bottom face, and then 4 going around the band in the center. So that means that there are 12 factorial ways to arrange them. But again, it's not quite that simple. If there are an even number of corner cubie flips, there has to be an even number of edge cubie flips, and vice versa. If there's an odd number, there has to be an odd number of edge cubie flips. So we really only have half the possibilities, because we've already determined the corner cubie orientation. So we're going to have to divide this by 2, because we have the 2 scenarios, even and odd. So that's the number of ways they can be positioned on the Rubik's Cube. What about their orientation? Well, the corner cubies only have 2 faces to orient, so there are only 2 orientations, 12 cubies. So you know the drill. That's times 2 to the 12. But again, it's not really that simple. So it turns out that you can't orient a single edge cubie. You have to do them in pairs. So 11 of the 12 edge cubies can be independently oriented, but the 12th relies on the orientation of the other 11. So we really only have 11 free edge cubies to orient. Now, the center cubies. This is where it gets interesting. And it actually is pretty nice for us, because it turns out you can't change the orientation of the center cubies in relation to each other. You can't change it, because if you change it, you're only moving the edge cubies and the corner cubies. You're not moving the center cubies. So it turns out there's 1 state, so we don't actually even have to factor that into the calculation. So that's pretty nice. Now we're ready to put the whole thing together. So the total number of orientations or permutations of a Rubik's Cube is equal to the number of possibilities for the corner cubies, so that's 8 factorial, that's the number of positions that the corner cubies can have, times 3 to the 7, that's the number of permutations that the corner cubies can have, times 12 factorial times 2, and I'm running out of room, that's the number of positions that the edge cubies can have, times 2 to the 11. Whew. I just had enough room for that. That's the number of orientations that the edge cubies can have. So what is this number? I'm going to have to cut away because I do not remember it. Let me write it real quick. So, this is the number. About 43 quintillion. It's a pretty large number. And that's the reason it's so hard to just randomly solve the Rubik's Cube. It's basically never going to happen because you would have to traverse through an expected number of 43 quintillion states or something like that. Probably slightly different. Probability is weird. But yeah, you would have to do all of that to just randomly solve it by chance. That's why we have algorithms. A funny thing is, the original marketing for the Rubik's Cube was that there were over 3 billion possibilities for the Rubik's Cube, which is massively underselling the actual number. This is orders of magnitude larger. So the marketing team really could have said over 43 quintillion states for the Rubik's Cube. But I don't know. Their loss, I guess. I don't know how to end videos, so you're just going to sit here watching me solve this Rubik's Cube. Maybe I can get it really close to the camera and it'll be like ASMR or something.